Hello students. In this video we'll see an example of variation of parameters. Let's solve the ODE y double prime minus y equals e to the x. To do variation of parameters, we solve the homogeneous problem. The homogeneous problem will be y double prime minus y equals 0. The solution to this is y equals c1 e to the x plus c2 e to the negative x. Now we assume that our parameters c1 and c2 are functions of x. So I have c1 of x e to the x plus c2 of x e to the negative x. And we plug it back into the original equation. So plugging back into the original equation, we will see that y prime is going to be c1, I'll drop the of x, e to the x, plus c2 e to the negative x times negative 1, because the derivative of negative x is negative e to the negative x, plus c1 prime e to the x, plus c2 prime e to the negative x. And the method of variation of parameters says that when you do the first derivative, the derivatives of the coefficients are set to be equal to 0. That gives us one of our equations. Then we simplify. Y double prime will be c1 e to the x plus c2 e to the negative x plus c1 prime e to the x minus c2 prime e to the negative x. And plugging it into the original equation, we see that y double prime, so c1 e to the x plus c2 e to the negative x plus c1 prime e to the x minus c2 prime e to the negative x plus y, which is c1 e to the x with minus, so it'll be a minus c1 e to the x plus c2 e to the negative x has to be equal to e to the x. Now we see that these terms over here and these terms over here will exactly cancel. And now we have our second equation. Our second equation becomes c1 prime e to the x minus c2 prime e to the negative x equals e to the x. Now we take our two boxed equations, which are two equations for c1 prime and c2 prime, and solve. So we'll call this equation 1 over here, and we'll call this equation 2 over here. If I do equation 1 minus equation 2, we'll see that the c1 prime terms will cancel, and we will get c2 prime e to the negative x plus c2 prime e to the negative x equals negative e to the x. Therefore, we have that multiplying by e to the x, 2 c2 prime is equal to negative e to the 2x. Therefore, c2 prime is equal to negative 1/2 e to the 2x, and therefore c2 of x is equal to negative 1/4 e to the 2x plus a constant c2. Now this c2 is a constant. So we've just found c2, so we can plug back into either equation. My first equation will tell me that c1 prime e to the x, and we know that c2 prime from this formula is going to be plus negative 1/2 e to the 2x times e to the negative x is equal to 0. So c1 prime e to the x is equal to 1/2 e to the x. By adding this to the other side of the equation, the e to the x's will cancel, and that tells me that c1 prime is 1/2. So integrating this equation, we have that c1 is equal to 1/2 x plus a constant c1. Now I have C1 and C2, so my solution y will be 1/2 x plus C1, that's my C1 function, times e to the x, plus -1/4 e to the 2x plus C2 e to the -x. And that is the solution of our problem. So variation in parameters says that you vary the coefficients of the homogeneous solution, and you set the terms that involve first derivative of the parameters equal to 0 when you plug back in and check. That will give you two equations, two unknowns, from which you can find C1 and C2. Thank you very much.